I'm Rob Napier. I'm going to do a quick introduction. Today's talk is just going to give you the big pictures about generics, and then if you want to go into all the gory details, we'll do that this afternoon. It's not supposed to hurt. Okay, in 2015 at WWDC, Dave Abrahams gave what I still believe is the greatest talk on Swift ever, including the Swift UI talks. Protocol-oriented programming in Swift. I watched it a bunch of times, and I took away this one line, start with a protocol. And so I did. I dutifully. I started with a protocol. I made my user protocol, my document protocol, my shape protocol. And I started implementing them, of course, with generic subclasses and all this wonderful stuff. And then, of course, can only be used as generic constraint. I've noticed a lot of other people maybe have seen this message once or twice. I answer a lot of questions on Stack Overflow. That's not what Dave said. I mean, literally, he said it. Yes. But this is what he actually said. For example, if you want to write some kind of generalized algorithm, then don't start with a class, start with a protocol. Don't start with inheritance, class inheritance. Try out a value type in a protocol first, right? He didn't say in all cases the first letters you should type in a Swift program are PRO. That was not the point. You're supposed to use protocols when they are useful. Instead of thinking about inheritance, the point was that we should be thinking about extensions and functions. What is the generic reusable algorithm that this protocol allows me to write? And when you think about the algorithms you want to write and the ways you want to use the protocol, you get a lot more power out of Swift. If I only give you one thing for this whole day, please take this away. Write concrete code first. Then figure out your generics, right? Start with concrete types, concrete use cases, right? And then find where the duplication really happens. Generics are heavily about removing duplication. But until you know where that is, how do you know what to pull out? The power of protocols is that you don't need to make all of those decisions early. With class inheritance, you really have to decide early what's going to be reusable. But with protocols, you can wait until you know more about the program or more about the problem. Okay, so what do I kind of mean? Let's try some real stuff. I'm going to do a very common thing you'd like to build, which is a general purpose networking stack, right? Something that can connect to a server and parse responses. Everybody builds these over and over again because the only thing we do in mobile development is parse JSON, right? But we also want it to be testable. Of course we do. So what do? We're going to start with a bunch of types that I fetch from an API, user, document, and these are just expressed in their most obvious way, in the way that the server wants to give them to us, right? Just data. And I've got this little client thing yet that's it's just kind of a placeholder. We'll figure out what goes into it as we go along. And the first client method, now, it feels like there's a ton of code here, but it's the same code you probably write over and over and over again, which is we're going to construct an URL session, construct an URL request, hand it to the session, parse the JSON. Okay, so this is literally, though, fetch a user. It is exactly concrete. Now I'm going to write fetch document. Well, that seems similar. Why does it seem similar? Because I cut and pasted it. Of course I cut and pasted it. I cut and pasted it, and then I changed a few things. What did I change? I changed those lines. That's when I know I just created generic code. The fact that I wanted to hit Command-C probably means, wait a minute, maybe I should be thinking about how to reuse something. That's the point to do it. And the act of hacking it up told me exactly what my parameters are. What are my parameters? I have document. I have this type that shows up all over the place, and I have this little string, right? So I can create it this way. I would say I'm going to hand in one of my parameters. You should think of these types. Model there is a type parameter to this function. It's a parameter that gets evaluated at compile time, but it's really just another parameter. And that works great, except for this one line that needs a string. Why? Because Codable doesn't know what these strings are. So I need a more powerful protocol. I need fetchable. I need to create a new protocol. Now, this is not a generic fetchable that you should go use. I'm not creating a general purpose networking stack. I am creating a networking stack that solves the problems of this API. And this API needs this little API-based thing. So I put it in my protocol, and I'm done. Great. Now we need to make, of course, user and document conform to this new fetchable thing. Now, we could just stick them directly here on the types, but I kind of suggest that you add it as an extension. It's really, in a lot of ways, it's just style, but I'm trying to make a point of a thing we call retroactive modeling. And retroactive modeling is the fact that Swift says you can take a type that you don't even control. You can take any type and say, I would like to use it in a new way, in this fetchable way. And in order to achieve that, I need to add some stuff. So I now haven't tied user and document to this one API, right? They're just what they are. They're just data. OK, so I come back to fetch, and I can use documents and users, and that's great. But I still have a lot of hard-coded stuff for networking, right? I'm tied to this URL session. And that it makes it it's hard to test, right? We all know it's very, very hard to test URL session because it needs a network. And so you might go, I'm going to mock URL session. Mocks are terrible ways to design protocols. Our goal is not to mock URL session. Our goal is to make an abstraction. We would like to abstract the way that you convert URL requests into data. That's the goal. That's much more powerful, right? If you wind up with a mock, what you typically have is a real object, a mock object, and a protocol, all of which are identical. Every time you change one, you have to change all three. That should tell you something's wrong, right? You're not getting much power out of your protocol because in your shipping code, you only have one implementation, and every time you touch one of them, you have to touch three of them. That's broken. Instead, what we really want to do, like I say, is we want to function. We want to convert URL requests into data. And so we express that function, and we're going to call it transport. Now, the neat thing here is retroactive modeling. I can now say URL sessions conform to transport. I do not have to wrap it up. I don't have to create, wrapper objects or extra classes or structs or anything. I can just say, hey, Apple class that I have no power over, you now conform in the way I would like you to. Same way I can go in here and say URL session data task, for some reason, does not conform to cancelable. I don't know why it doesn't conform to cancelable yet, but I can just say it does, and I'm done. OK, back to our method. So what do we actually do? Now we're calling the transport. Cool. And now a transport we have the transport. It fetches data, and it hands it to a completion handler, which parses after I parse the results. And of course, now I need transports. I don't know what my transport is, which is why I created the client class in the first place. The client class exists so that I have a place to hang the transport and make it the default because, you probably want the network most of the time. OK, I'm hoping out of that you can now imagine how you would make a mock transport for unit testing, one that you loaded up with data and you handed and you got the stuff back in a unit test. I'm not going to talk about that because it's boring. I don't want to talk about boring protocols. I want to talk about actually really interesting ones, like what if I had a transport that modified other transports? What if I had composition? Well, I could have a transport that adds authentication headers or authorization headers to other authorization headers to other transports. So this is a transport. I hand a transport and a set of headers, and I say, everything I hand you, update with this extra header. Well, now I've separated concerns. I pulled my authorization step out, right? All that token handling is now not part of the transport. It's part of this wrapper. And now when I build my unit tests, I don't have to swap out the add header stuff, right? I don't have to mock it, because it just works. All of that works. The only part I have to swap out is that bottom piece. So these are the kinds of things I want you to be thinking about, is like, how do I use my protocols to combine together to form other things that are more powerful? That's the whole point. Protocols are for algorithms. If you're only thinking about them in terms of putting them into arrays, you're not getting the power out of protocols. That's not really what protocol-oriented programming is about. Protocol-oriented programming is about algorithms that can be reused, generalizations. Write concrete code first, right? And so far, I've not yet pulled out an associated type. All this. Thank you.
We have a few minutes for questions, but we'll try to be short, and as you will talk this afternoon, maybe people who want to go deeper will have the opportunity to do that. I really like the approach of repeating, like, you need to start with the code, and then only after that you extract the generic behaviors. And it's true that sometimes we already think about architecture, how you extract, how you architect the code, and sometimes it's easier to just put down the code and then sort out.
I think the thing that people most miss is that abstractions are choices. Every time, there's no such thing as generic as possible. That doesn't mean anything. You need to, every time you say, I'm going to be flexible along one direction,
yeah, it's not just
you
one
are making
direction.
the other direction, a lot of other directions, you're making harder. And when you're starting at the beginning of a program, you don't know yet which pieces need to be flexible. And you'll almost always, the number of times I've gone into a program and had all this flexibility that was built 4 years ago, we've never used it, and now it's getting in the way, and I have to take it out.
Yeah.
Because we wanted to be flexible a different way.
Actually, we had a question from the audience about something similar. Is like, there are some languages where they have generics, they have been using generics for years, and sometimes it becomes a mess, like it's generics of generics of generics, it's layers of on top of layers.
Yes.
Exactly. So do you have some advices to make sure that you don't fall into that pitfall?
Well, and this same philosophy really applies over there as well. So Java in particular has often suffered from...
I haven't said the word.
I know, but it's important. Java's not bad. Java is a place you want to look to because they have a long history, and they have evolved many, many times, and so we should constantly be looking at all these other languages. We should definitely be looking at JavaScript. What have they learned? What has Haskell learned? What have all these other places? We don't have to reinvent this stuff. And the way that we avoid it is we don't build it until it's really kind of useful and we can see how things evolve. Both Java and C# have often suffered from jumping to generics in the language in ways that are convenient. They were very easy, but now they have code that can actually crash. There's a number of things in Swift where you think it's making your life hard, but actually, well, I can do this in C#. Yes, but in C#, if you do anything wrong, it'll crash.
Yeah, we really feel when you look at this language at Swift, you really feel that Apple looked at other experience.
Absolutely.
Yeah, actually, it's a trade-off of such a language as well. I mean, it's the safety that imposes this as well.
Well, and you often find when you're thinking about, I'm going to make this generic, it's like, have you thought about all the weird ways it could be used? Or are you only thinking about your one use case? And if you only have one use case, why is it generic?
Yeah, absolutely. Yeah.
And do you have unit tests? I think the biggest thing is when you add something and say, well, I'm going to handle all kinds of things. So you have tests for all of those different use cases?
Yeah. that's also a good way to spot. Like if you are not covered, then
I don't know if you might find the answer in today's talk about testing, but might be. We'll see that later this afternoon. Anyway, you want just to say one more word about your masterclass today?
Sure, sure. So a lot of what I talked about today is use less protocols. What we'll talk about this afternoon is how to use protocols.
Very good.
thank you.
Thank you very much.
Thank you very much, Rob.